So, hello again. Here are the guys from Germany. Today with Achim and Frank.
Good
Thomas
morning.
Thomas will join us tomorrow again, and we got only some seconds left until day 4 of Advent of Code will start. 3, 2, 1, and then we go. So here it
And
is.
open. Oh, we need to clean up the camp. Okay, the elves have the camp is divided up in sections.
Big list of section assignments for each pair.
And some of the assignments overlap. So we need to find the overlaps and eliminate them, I believe. How many assignment pairs does one range fully contain the other? Okay, so we go through the list and check for each if the two pairs if the two section lists are given there are completely covered by the other for each pair separately, and count how many are subject to that condition.
So these are segments, and we want to find these pairs where one segment lies completely within the other segment. Okay?
Yes.
So just let's write down the code. So first of all, we need a nice parser, isn't it?
Yep.
How many? Okay, just count them.
Half of the parser done. So,
I got difficulties to implement my parser correctly here.
I'm starting it now for the first time, and it tells me that I got 406 of those items.
Sounds not too
And that's
bad.
wrong.
Not wrong?
Yes. Crap. Oh. Error found. I made a copy of the set, but then didn't use it and destroyed the original one. Not that good. Retry. So, next try. But probably I have to wait now. I have 24 seconds left to wait. Yay. 11 seconds. 3 seconds. Nah. Eh, still not it. Damn it.
I got 25 seconds left.
Okay, I don't know where the bug is, so
So debug
I'm
it.
putting up I'm taking the sample data as test data. Shit, now it finds nothing.
Okay.
Third bug found, but
Okay.
only by chance. So, okay, test data result seems fitting, so I try again. Yes, it was 524. Part 2.
So part 2,
Now they want overlapping
yeah,
stuff.
count all that overlap at least one position. So at least the parser stays the same.
Yeah, but now I don't use remove all, I use retain all as yesterday.
Yeah, but basically you want to find an intersection and check if it's not empty.
Yes, but I'm using sets, so I can use the retain operation for that.
Oh, you can. You can retain the one from the other and the other from the one, and when both are not empty, no. Then,
Exactly,
that,
I'm doing exactly that.
yeah, okay. So I did it with a
Uh,
simple if and compared the numbers. So the right end to the left end.
and as I already put in the test data set, I can run it as well. And run. So, okay, that was test data is yields 4. I have that. And then 798 might be the... Yes! I did it.
Very nice. So let's have a quick look over the thing. So for me, the harder part was getting the parser right. I first thought about reading it line by line and then simply substituting the minus signs and the commas by white space, and then I got four numbers and can simply parse the numbers. And substituting these minus signs and commas was too much for me this morning, so I had to figure out this for some minutes until it worked, and then it was more or less straightforward. The comparison of the right ends and the left end of the segments more or less simply gives the result. It's yeah, well, if the one is in the other or the other is in the one, then we simply contribute this line to the answer and then put it out. And basically for the second part, it's the same, only the condition when we count changes a little bit. It looks like this in my code. So the parser is the same. So yes, was a nice riddle. Not so clumsy as yesterday. What do you think?
Uh, for my part, I was a bit clumsy, so that's why I performed so bad. But yes, it's a nice task. For my code, as you can see, the calls for part 1 and part 2 are double now, so that I can use the test data set.
Yeah.
But if I look over the methods for part 1 and part 2, could have folded them into one because they are quite similar. So what am I doing? I have the input read into a list of strings, line by line.
Mm-hmm.
And this for loop goes through each line and splits them by the comma. So I have the left and the right part. And I pass them by using the split method again, now on the minus. So I get again two parts because it doesn't have anymore. And get the lower and the upper bound. And then I go through this for loop. Add them into a set. I could also, for that few numbers, it could also be a list or something. It doesn't matter. The important thing, it's a collection. So when we come back into the part one method, it checks whether the left one is completely within the right one or the right one is completely within the left one.
Yeah.
And to do that,
this is funny thing, because if these segments would get very big, you would become very slow, because consider there are segments in the size of like 100 millions, because there are big integers used in the input data. Then it would be very slow. But okay.
Maybe, yes.
Yeah, the bigger the numbers, the slower you code here. So
you're right.
Because
if the numbers get very big, there are more efficient ways to do that by having some kind of descriptor. I start at there, and I start at x and at epsilon, and yes, there are ways to do that more efficient.
Yeah. But okay, it works.
But for this, it is enough.
Yeah.
So this makes a copy of set A named C and removes all elements of B from C. And if C is empty by that, it means that it's completely inside of B.
Yeah, makes sense. So you basically check if the intersection has the same size as one of the sets. If this is the case.
Now for the bugs that held me up.
Yeah.
I didn't wrote C here, but A.
Yeah.
That was the first one. The second one, this equal sign was missing, so
yeah, okay.
I didn't include Y1 into the set.
I double and triple checked this point also. Yeah.
This wasn't C as well, but A, and that was then a total disaster.
Yeah, there's little bugs, and once we are in debug mode, this is not a good thing. So this needs a lot of time. So with these simple riddles, it's most likely the best to write it down on first try without these flows. Yeah.
For the second part, I recycled the parse section list method and adapted the complete coverage method into a new overlaps method. Working roughly the same, but this time instead of using the remove all, the retain all. So this retains every element that is also within there, so creating an intersection. And if this contains any element afterwards, we have an overlap.
Yeah.
But yes, that could have been done more efficient. So you could take the so for a more efficient method, if the ranges get a lot bigger, it makes more sense to do a split on the comma and the minus. So the string array would contain 4 values.
Yeah, exactly.
And we would exactly know which one is it? Is it? And for example, for the overlapping, we would then check if the third element is somewhere in the range from the first to the second.
Yes, exactly. So I parsed it in a left one, right one, and left two, right two, which are the two segments, and then it's if the left one is between the two other ones, or if the right one is between the two first ones, then the condition is fulfilled, and we need to count this line. Yeah, that's it. And the second part, it's even simpler. Then we need only compare if the right end of the left segment is left of the left end of the right segment, which compiles to if R1 is
Yes,
smaller than L2 or L1 is bigger than R2, then we count it. Yeah. So,
that would be faster in computation, but I don't believe that it's faster to code. More like the
well,
opposite.
well, it is. Okay. Every
Using the sets makes it easier to code down.
Yeah, okay, there are preferences from developer to developer. The one likes it this, the other likes it that.
And
So,
these set operations are, well, they can get very helpful.
yeah, of course, of course. So, I think we are done for today. We will probably meet tomorrow, same time, same place, to solve the next riddle. I thank you very
Yeah.
much, Achim.
Bye.
Bye.